This is Randy Brooks. I'm the Extension Forestry and Fire Outreach Specialist with the University of Idaho, located in Moscow. And I appreciate the opportunity to be here today and talk to you a little bit about fire and fire ecology. And I've got a PowerPoint here, and so we'll have a little bit of interaction as we go throughout the next 45 to 50 minutes or so. And I want this to be as interactive as possible. So if I say anything that doesn't make sense, go ahead and unmute your microphone and just say, hey, Randy, I didn't quite understand what you said. And then throughout the course of this, I'm going to ask you to give me some answers in the chat box if you know where your chat box is. But anyway, so what are we going to talk about today? Here's an outline. I've already told you a little bit about who I am as an introduction, but a little background on me. I grew up in Oklahoma on a small farm, and we had more range than we did trees, although I ended up going to college to be a forester. I went to Oklahoma State University, and I grew up milking cows, haying, all those kind of fun things, so kind of a farm boy at heart. Then I want to, so we'll use that as the introduction. Then I want to give you some wildfire facts and statistics. I always like to throw numbers out there because I'm that type of person that just likes to see stuff like that. And then I want to give you a definition of fire ecology and talk a little bit more about what that is and how that works. And then a definition of wildfire, because when we're talking about fire, there's a couple of types of fire. There's wildfire and then prescribed fire, which is the intentional use of fire. And then I want to talk about science and elements of wildfire. And don't get too wrapped up in the science and definitions. I want this to be as less techy or technical as possible. But then I want to talk about people who study fires, because there's a whole science, or there's a whole arena of people that actually study fire, and I'm actually one of those that do research in fire. And then I want to throw out some rangeland fire and facts, since this is for the Rangeland Skill-A-Thon. I actually have a much stronger forestry background, forestry fire, than I do range, but a lot of the things that happen in the forest with fire is similar to what happens in the range. We just have different types of fuels and systems. So we'll talk about some management strategy, and then I'll have a little bit of time there at the end, hopefully, for questions and some question and answers time. So, like I said, I like to always throw out statistics, and here you can see from 1990 to 2019, the annual wildfires and acres burned in the United States. This isn't global. This is across the United States. And so you can see over on the left, the red line, that's fires in thousands. So in the year 2007, we almost reach 100,000 fires. Those are fires that happened across the United States. And then in last year, in 2019, we had about 57,000 fires. And if you think of that on just a big scale, like across the state of Idaho, across the West. And most of these fires do occur out West, by the way. And we'll talk a little bit more about that, or if you have questions about that, feel free to answer me. But what's really interesting is our fires are getting bigger and bigger. So if you look at the gray area on this slide, the acres burned have been, I don't want to say horrendous, but it's been massive. 2015, we had more acres burned and more fires than ever. 2015 was one for the records. And if we look from the beginning of the 2000s for the last 20 years, this is when we've had the most fires and the most acres burned. So our fires are getting, in my mind, and the data backs this up, they're getting more intense, and we're having more fires, and we're burning more acres. So here's the top 5 years with the largest wildfire acreage burned since 1960. And so if we look over the last 50 some odd years, like I mentioned, 2015, we burned in the United States alone over 10 million acres. And it's hard for me to even fathom a million acres, let alone 10,000 acres. And then we had 68,000 fires. And the only time we've ever had more fires than that was in 2017, where we had over 71,000 fires. So this is a fact that we're going to have to learn to deal with. Fires are getting bigger. And if you look, it's been in the last about 14 years, last 14 years, we've had our biggest fires. And so as we fire people, fire scientists that study this, look at trying to predict, and we can't always predict. I thought the 2020 season was going to be a big year. We haven't seen all the stats out there, but anyway, so we'll see how 2020 turns out when all those numbers end up. I've got some of my students in our fire program here at the U of Idaho are still on fires down in Colorado and California. So we still have, even though we're reaching mid to end of October, we still have fires going on across the United States. And then here's one thing that's really, really interesting to me is our fire season. If we look since 1984, and this goes to 2010, our fire season has increased by a month. So from start to finish, our fire season is actually over 30 days longer. And if we get that projection now from 2010 to 2020, I think we're going to see our fire season is close to 35 days in length, if not longer. And there's parts of the country like California that now they don't even have a fire season. Fires go year round. And so as we learn how to predict this and work with the fires, I have a son that's a smoke jumper, and so he's fighting fire all the time and loves what he does. But there's more and more fires every year, and the fires are lasting longer.
I had a question. Yes. So I don't know if you're going to talk about this, but is there a reason why the season is increasing? Or do they know why it's getting longer?
Well, so I've actually got a slide, and I'll talk about it in droughts. But one of the reasons is we've had a change we actually haven't. The state of California, for example, they're not managing their forest lands, at least on federal lands, and so we've had a buildup of fuels, which I'm going to talk about a little bit later on, because we have excluded fire, like Smokey the Bear campaign. Smokey, what did Smokey say? He says, put out all forest fires. And so that's what we did, starting after the fire of 1910, which was the biggest we had ever seen in this country, burned up a good chunk of the West and the Pacific Northwest. And so what we've actually been doing is working very hard to put out the fires, whereas 200 years ago, 500 years ago, we didn't have firefighters. The fires just burned. And so we see that what we've done is stopped the burning, which has increased the fuels or the fuel loading. And so I'll delve into that a little bit more, but that's a great question. Thanks for answering it. The other thing is, and you can find debate on either side of this, is climate change. Is it real, or are we just in an up cycle or a down cycle where we're just warmer and drier? And I've got a map I'll show a little bit later on where the U.S. is with droughts right now. And we'll see that that's where the majority of our wildfires are taking place. So thanks for that question. Good question. Okay, regardless of where you live across this great state of Idaho, fire is a natural part of the ecosystem. I just kind of alluded to that. We have, as long as man has been around on this earth, there has always been incidents of fire. And we've learned how to control that, use it for cooking and things like that. But it's the uncontrolled wildfire. And if you look, maybe you live in in Twin Falls, Idaho, where we have a lot of irrigated potatoes, like on picture C there. I live in where picture F is, in the forested part of North Idaho. Tyann probably lives down around B, as well as Nikki and some of you all. But regardless of where we live, fire is always a threat. It's whether we're in the range, whether we're in the woods, or even in your hay fields, fire is always a threat. So again, one of the points I want to make is fire has always been a natural part of our ecosystem. It's always been here. It always will be. And like man is always, like we've always tried to tame it or put it out. And so that's kind of led to some of the issues that I'll jump into a little bit later on. So I want to give you a definition of fire ecology, and this is the kind of the wordy techno geek kind of definition, but it's just a discipline. Fire ecology is a scientific discipline that looks at the natural processes with fire in an ecosystem and the ecological effects. So how does fire affect the rangeland ecosystem? How does fire affect the forested ecosystem? And then the interactions of the fire with the living and non-living components of that ecosystem, and the role of fire as an ecosystem process. So there's a lot of things going around. Basically, fire ecologist is just, it's a discipline or a study that, well, we study fire and how it behaves and interacts with our ecosystem. So I want to ask you, the audience, is fire good or bad? And I've kind of been alluding to that. So if you want to look, go ahead and type your answer in the chat box. And there's no right or wrong answers. But yeah, so we can see all sorts of reactions here. I'm going to give it just a little bit more time. But so let me answer that for you. Is it good or bad? Well, it depends on who's asking. Here's a picture of a fire in August of 2000, and this picture has been made famous. I've seen it in almost every publication. You can see there's a fire raging in the background. You've got embers going up. The fuels, which in this case are the trees and the downed woody debris that's on the ground there, they're all on fire. And if we look at the background, you can see 2 years later, other than some dead trees back there, it really doesn't look too bad. But let's go from my perspective as a forester. When we harvest an area and we're left with slash, and I equate this to someone that has just harvested their grain, and they have all the grain stubble left behind. Probably the most effective economical way to deal with that is to burn it. And so that's where fire is good. In a forest, we're left with all the limbs and the woody debris from the harvest. And so it's easier for us to burn it and then go back and replant. And hence the analogy I used with farming with our weed stubble. One of the other things is fire. If you've ever walked into a forest that was really, really thick, and so you go and there's nothing but shade, there's no sunlight hitting the forest floor or the ground, there's no wildlife browse growing underneath there. So fire can be a good thing for wildlife. As a matter of fact, when we see the year after wildfires or even prescribed fires, we see that wildlife usage can actually become much higher from the wildlife browsing in there. So there's a lot of good things that are associated with fire. It can clear the undergrowth, the brush, the fine fuels buildup and things like this. Well, here's the bad side of fire. When we start seeing damage to our homes, to our communities, and a lot of times we see the picture in the top left there the whole hillside's on fire. Well, people love to build their houses in the woods. You can see the picture there of the house with the chimney standing on the right. That's unfortunate. Mankind has actually blended in with Mother Nature on where we want to live. We like to have trees around us. And like I said, we live especially in the West, in a ecosystem that has always had fire and has always dealt with fire. So whether you answered, is fire good or bad, you weren't wrong. So, but let's talk about wildfire. I think we all have this mental picture of what wildfire is. So I'll just ask you to pause for just a minute. In your own mind, what does it look like? I think we can all envision those big flames going up. What does it sound like? If you've ever been, I've done a lot of prescribed fire. Fire can be really loud. And then what does it smell like? I think we can all associate the smell of fire, and we all have different pictures of it. And as for me, when I was about 14 years old, we actually had a wildfire burn down our farm. We lost 3 barns. The only thing we didn't lose was our house. So I've been a victim of wildfire, and I know how that feels. So how would you define wildfire? What is wildfire? Well, I'll make it easy for you. It's just an unplanned and an uncontrolled fire that spreads through some type of vegetative fuels. And when I say vegetative fuels, it could be trees in the forest. It could be sagebrush and grasses and forbs on the rangelands. And those are what vegetative fuels are. At times that can involve structures. And we hear a lot about the fires in California. So many people in California they're building in the woods, and we call that the WUI, W-U-I, the wildland urban interface. And so when we put ourselves out there, we run the risk of we're living in a fire ecosystem, and that's just how Mother Nature is. So here's a good little paragraph that talks about wildfire, and I've alluded to this kind of all throughout my talk so far. Wildfire is an historic and natural part of Idaho's rangelands and Idaho's forests. However, historical fire regimes throughout the West have been altered primarily due to cheatgrass and woodland encroachment. I'm talking Idaho rangelands. They have been impacted by multiple mega fires during the last decade. And I won't read the whole thing there, but I'll pause for just a second for you to take a look at that. But we do have some very effective and successful fire management strategies that, A, most importantly, increases human safety, and B, protects our valuable lands. And it's the Rangeland Fire Protection Association, which was organized in 2012. And the Rangeland Fire Management Protection Association is supported by state and federal organizations that help fund ranchers and farmers and others to fight fire on rangelands. And so it's been a very effective and what I would call a best management strategy for dealing with wildfire. So any questions so far? So here's a map of Idaho. And this one, again, there's no right or wrong. And you don't have to answer in the chat box, but just for a minute, where would you predict wildfires to happen in Idaho? And so if you can make out the legend on this, the green is the Forest Service, primarily forests. The brown, or I guess it's a light tan that we see dotted across southern Idaho, is the Bureau of Land Management. Then we see some Bureau of Indian Affairs and a lot of private ground. And we get the red arrows, especially in the panhandle, and then scattered throughout the state is the state of Idaho. So go ahead and just in the chat box, where would you predict the wildfires to be? And again, this this is hard to predict. Even us fire scientists, we can't predict where the fires are going to be. There's a lot of sorry, I was looking at the chat. There's a lot of things that go into predicting fires. So I'm going to come back to that. But there is the science of wildfire. How do we predict things? Well, the fire has to have three things, and we call that the fire triangle. It has to have oxygen, and it has to have heat, which reacts on the fuels. And I've already mentioned fuels earlier. Fuels could be sagebrush, it could be grasses, even cattle manure, dried cow patties, so to speak. Those could be fuels. And then in our forested ecosystems up north, we have the trees and the vegetation and the shrubs growing underneath. So what is the source of the oxygen? Well, that's air. What's the source of the heat? And then what's the source of the fuel? And so we call this the fire behavior triangle, because we have to have all three of these present, working together to create a fire. And the amounts of each of those can dictate the intensity of the fires. So how does weather affect occurrence and spread of wildfire? What's the audience think? Would a hot, dry summer day affect the occurrence and spread of wildfire? Or would a day like today, where it's kind of misty, rainy, high humidity, and cool? Yeah, the hot, dry weather like we see, and that's when our biggest fire season is, July, August, September, when it's really hot and dry. And so the fuels are dried out and they're more susceptible to fire. And then which types of fuel feed a wildfire? Would grasses feed a wildfire more than sage, more than small trees and brush, or big trees? So it's the type of fuel. And then topography. How does topography, I see the answers coming in there on the chat box. How does a topography affect the occurrence and spread of wildfire? Well, Idaho is a very topographically diverse state. We had a lot of canyons, a lot of steep slopes and things like that, and that affects fire. Fire can burn very fast moving uphill. And on the other hand, when you get out on the range in southern Idaho on the Snake River Plain, we can have flat topography. And so the fire may not spread as fast unless there's wind. And so wind is part of that weather and how weather can affect the spread of wildfire. So there's those essential elements of fire. The heat is, there's got to be a source to light the fire. For example, it could be a human striking a match, flipping a cigarette out on the ground. It could be sunlight shining through some type of a glass bottle. But in the most cases for natural fires is lightning. Lightning will strike something where the fuels, the best part of the triangle that burns, or the part of the triangle that burns, if the conditions are right, the fuel's there, then the fire can get ignited. And then oxygen, we got to have oxygen. And essentially we have plenty of that in our atmosphere, and that comes from the atmosphere. So again, fuel, the parts of the forest or rangeland that can carry the fire, and then topography, which is the slope and lay of the land and the direction it faces. South-facing slopes are usually much warmer and drier than north-facing slopes, and there tends to be source of ignition, or at least carrying the fire on those slopes, which can spread over in the north-facing slopes. And then weather. The weather conditions have to be right for the moment for the fire to start. So any questions so far? So we don't have to answer in the chat box unless you want to, but how many types of fuel can you think that exists in your home and around your home? Well, I can think of my own self out in my garage, my shop. I have gas cans, and I have gutters on my house, and I have pine trees. And so I typically will have pine needles in the gutters of my house. My house is built out of wood. I have wood siding. That's another type of fuel. So what about rangelands? What are the fuels? And I've already alluded to this. Yeah, most of you probably think, well, the sagebrush, the grasses and the forbs. And I mentioned cheatgrass. Cheatgrass is very invasive, and it grows up really fast, and then it dries out really fast. It matures, it comes to a seed, has the seed heads. And so that becomes an issue. It dries out really fast. What about the forests? Obviously, our trees, and every year, trees, even though pine trees or conifers are what we call evergreen, they're always green, they lose their 3-year-old needles. So if you've ever been in a thick ponderosa pine forest, you're walking around on a bed of dry needles. Well, depending on the season, you're walking around on some very fine fuels. And those fine fuels get started, and then medium-sized fuels get going, and that leads to our bigger fires of our trees. Okay, there's this other word called fire regime that us fire scientists or fire types would talk about. And so that's just the pattern and frequency of brush fires and wildfires in an area over a long period of time. And I know across Idaho and in the rangelands, we commonly had fires commonly occurred every 5 to 60 years. And as I mentioned earlier, we have decreased, or what we've done is tried to put out those fires. So we've actually eliminated fire from our ecosystem, and we've allowed the fuels, the fine fuels in our forests and the grasses in our rangelands to build up. And so we have fuel loads, and this comes back to Nikki's question from earlier, that we have historically never seen. And so you walk into the forest and you've got this accumulation of materials that typically would have burned anywhere from 5 to 50 years ago, and then the cycle starts over. And so that's what we've actually seen. Our fire regime is actually, it used to be quite frequent, and we changed that. Okay, so I've been talking about the essential elements of fire, and on a large scale, if, when we're talking about hundreds of thousands of acres, a particular climate is necessary for a fire regime to happen in an area. And so for those of you from southern Idaho, what's your average annual precipitation down there? Yeah, it's not very much. And so we have a dry climate, especially in July, August, and September, where the climate is there for a fire regime to happen in that area. And then ignition sources. What types of ignition sources are around the area? We have a lot of humans that go out and camp on our federal lands in our national forests. And a lot of times just simple carelessness with our campfires. And then in Idaho and the West in particular, we have a lot of dry lightning in the summertime. And so these dry lightning might hit the ground and start sagebrush or grass on fire. It might hit a tree. The tree would smolder for several days, and then it just ignites and goes. And then again, the vegetation that I've been talking about. What types of plants grow in your area versus my area? Are they susceptible to fire? And can they grow back? And I'll touch on that a little bit later about can they grow back. So any questions so far? I want to look at some factors, and I mentioned this drought monitor, and this is the most current as of October 13th. So about, it was released yesterday on Thursday. Let's look at the U.S. drought monitor. And so the brown areas that you see across Utah and Nevada, Colorado, southern Arizona, that is exceptional drought. That means the drought is just beyond extreme. All of the red, look at the extremes. We only have that little bit for those of you down in south central Idaho, a little bit around, looks to be around probably north of Twin Falls, Blaine County, up through there. But check out most of the west. If you don't look at that and think, wow, and then we've got severe drought, and then yellow, abnormally dry, and then the white, there's none. You look at Idaho, most of Idaho, other than that little sliver up there or around the Salmon River country, is we're in a drought. And like I said, most of the west has been in a drought. And so that means all those fuels that I've been talking about, they're dry. And so the bottom part of that fuel triangle that you see there, the fire triangle, is the fuels are dry. And so that's our weather patterns. And our weather patterns right now are conducive for wildfires. And like I said, I've got a couple students that are in Colorado right now that are in that severely or the exceptional drought area. And all it takes is one, mistakenly thrown match or an ember from a campfire or a cigarette or something like that, a lightning strike, to get this going. So that's weather. What about topography? I mentioned a lot of Idaho. Look at the rugged terrain we have in central and north central Idaho, and even the Panhandle. Steep slopes. Fire carries rapidly up steep slopes. And so topography plays a huge role. So you can see there's a little screenshot of some of the fires that have occurred in the west, especially there in Idaho. So what about fuels and vegetation? I had a hard time finding the fuel loading for the rangelands, but these are the predominantly forest types in Idaho. And so look at the density. The darker green is the very dense tree growth. And the more trees we have, the more density we have. Trees compete with each other. They compete with each other for sunlight, because all plants photosynthesize. They compete with each other for moisture and nutrients that they get from the ground. And so when you've got a very dense forest, and I realize this is for a rangeland Skill-A-Thon, but it kind of sets the background for some of our fires. The denser the forest we have, the more competition we have, between trees, but also as this competition occurs, and it can occur in rangelands too, when the plants are competing, especially in southern Idaho, for moisture. If enough moisture doesn't exist or is inadequate, the plants will become stressed. And once they become stressed, they become weakened, and they can eventually weaken to the point to where they succumb or they die. And so we've seen, especially in our federal lands, a predominant buildup of fine fuels. So a little bit about the science. I've been talking about wildfire and that triangle about what it takes to make a fire, but let's talk about how fire spreads. Because even if I were to throw a lit match on a patch of grass, it's got to spread before it starts to burn. And so it does that through heat transference. And there's a couple different kinds: conduction, convection, and radiation. And then the biggest fire spread is I've got there, and I'll come back to those three words there. But ember displacement. So here's a great picture I've got over here on the right of the screen of embers. And we've actually, through some of the research here at the University of Idaho, found that people will say embers can go a mile. We've actually seen embers that can carry in the air in wind for up to 5 miles or further. And so if you've got an ember 5 miles away from my house and it actually lands in my gutters full of pine needles, and if they're dry, what are the chances of that wildfire spreading? It didn't even spread to my gutters. It could just spread through the forest or through the rangelands. So ember displacement. So surface fires spread through radiation. And so you can see these different illustrations I have here. Crown fires by convection. Now the wild card in all this is the ember movement. And that's the potential for those embers to move, especially in windy conditions. Fire actually creates its own microclimate. And so the hotter it gets, you see that picture there in the bottom right of the trees that are on fire, you can actually see the flames roaring up and the embers going with that. So burning embers can be carried, I've got down here, by more than a mile, commonly by strong winds. And so your heat output, and that's what, I've got the word loft there, that's what carries the heat. And so when I say fire travels faster uphill, it creates its own climate as it moves. And then the wind field, or the transport of it, and then what's going to what fuels the receiving fuel bed. So it could be your house, it could be your yard, things like that. So fire spread is what gets is probably the most important thing, next to the fuels and the how dry the fuels are. So am I making sense for everybody? Okay. Now here's a good example. We've all heard this. We have ignition and we have liftoff. If you've ever watched the space shuttles, here we have liftoff and ignition. So look at those embers there in that center picture. You can just see the embers flying through the air. The chances of something catching on fire, like that roof with all the pine needles and pine cones on the top of it, man, that's our sources of ignition. Okay, so where did you predict the wildfires would go when I asked you that earlier? You know, for me, I would have said wherever the fuels are the thickest. But again, it also depends on, like I said, climate, precipitation, and all those other things. If you look at that little spot down there in south central Idaho where it's in exceptional drought, that's where a lot of fires have been. Here's a good slide that shows, this is rangeland fires. And so you can see, look at all those, each red dot represents a range fire. And you can see all of those little red dots that added up in southern Idaho. Again, historical fire locations larger than 300 acres. Okay, so let's take a look at some of our very historical fires. The Murphy Complex fire, it's been almost 13 years now, but I remember this like yesterday down in southern Idaho. It burned 652,000 acres. And fire doesn't recognize jurisdictions or boundaries. It will go from your private land, it will go from Forest Service land, it'll burn up your fences, it will cross your fences. And then that same year, the Milford Flat fire in central Utah burned 160,000 acres in one day. That's just unbelievable, just phenomenal. And then the Long Draw fire, 557,000 acres. The Buzzard Complex fire in 2014. And then the Soda fire, that's the most recent one we have in our memories, almost 300,000 acres, 280,000 acres that have burned. So it's not just the forest lands that burn, the rangeland burns, and there's consequences to those. But so now let me tell you, we've talked a little bit about fire, the fire triangle. What about who are the people that study fires? And for us here at the University of Idaho, we have several fire ecologists who just study the processes that link the natural incidents of fire in an ecosystem and the effects of fire on the ecosystem. So what happens, we've got a lot of them studying, well, the rangelands burned, you know, and we have some rangelands, we've got some range scientists that are actually looking at this as well. What are the effects of our ecosystem. What happens to the rangelands? What happens to the forests? What happens to our grazing? In most cases, it comes back pretty quick, but here's another interesting one. A dendrochronologist, that's a scientist who uses tree rings to answer questions about the natural world and the involvement of humans. Dendrochronologists study fire by looking at the growth rings within the tree. They count the rings and look how thick they are, and then they look for fire scars. And that's what, when I told you that fires have regularly occurred across the West in 5 to 60 year increments, that's how we've done that. We'll take an increment bore into a tree, and you can look for fire scars. And then we can predict, going back, how often fires, and that's how we know fires have always been a natural part of our ecosystem. And then archaeologists will study fires as well. They'll use science to study the past cultures and the way people live based on the things that they left behind. They'll investigate old villages, they'll interview descendants, analyze their plots and things like that. So that's some of the people who study fires. And here at the University of Idaho, we have a whole degree program based on fire ecology. And then a climatologist, that's a person who studies climate change, climate variation, and the effect of the climate on the biosphere. And that's just the living world as we see it. They look at all this climate data that's been collected through instruments, as well as looking at tree rings, pollen deposits in the rocks, and then glacier markings and deposits from the river. And so there's a lot, like I said earlier on, there's a lot of speculation on, is our climate changing? Are we getting hotter? Are we getting colder? Everybody thinks we're getting warmer, or is it what we just call natural variability? We had a rainy spring up here in North Idaho last year. We hadn't had that for a while. So it's just part of this natural ebb and flow. So we don't know. We haven't been, as scientists, collecting data long enough to know, what are we really looking at here? So as I close this thing down, I've always got this saying, it's not if it's going to burn, but when it's going to burn. Because like I said, fire is a natural part of our ecosystem. And so what we have to do is learn how to live with fire, especially in terms of land management. And so one of the things we can tell, especially with trees, is, in southern Idaho, you have a lot of ponderosa pine. You've got lodgepole pine as well, and you've also got I'll come back to it. But anyway, ponderosa pine, Douglas fir was the one I was thinking of. Had a little memory lapse there. But Douglas fir and ponderosa pine actually have thick bark, and we think that these trees have adapted to fire over time by having a thicker bark, and that bark insulates the trees from the fire cooking the cambium, which has the xylem and phloem in it, and killing the trees. But how can you tell if plants survive? Well, it depends on where the growing points are. And so if we look at the sage there on the right, sagebrush, the growing points are on the tips, whereas the grass, they're at the ground level. And so this enables grasses to survive better than sage when fires go through. However, the beauty of these plants are sage typically has a very deep rooting system. And so oftentimes, not always, but oftentimes if the roots don't get cooked or baked, plants can survive. And so here's a good example of root systems. You can see that sage brush there on the left can actually go down close to 6 feet with the roots. And that's what enables them to survive in that, what I call the arid climate of southern Idaho. They can get those tap roots down there and tap into the water that's down there. And then there's some of our grasses as well. But there's the thing about, I've got deep-rooted perennial bunch grass, which are natives to our rangelands, versus invasive weeds that are not in native. And invasive weeds are more aggressive, and they grow faster and quicker and mature quicker and produce seed. The whole idea behind a plant is produce offspring or produce seed. And so they're very, what we call competitive. Excuse me. So they can outcompete these other plants. However, they're not very deep rooted. And so there's a lot of factors that come into play when we're talking about which plants survive and which don't. But what we've seen, what the science is showing us, especially with some of our University of Idaho scientists, is the more cheatgrass we have, more wildfire, which causes more cheatgrass, which causes, so we're in this, I don't want to say vicious cycle, but I think we're in this cycle where we've got to figure out a way to eliminate cheatgrass, which is a non-native in Idaho. So what are the ways that we're managing our rangelands? What are some of the ways where we can reduce fire severity? And the biggest one is grazing. Grazing can decrease wildfire risk. It also increases resilience to wildfire, where if they're by lowering temperature, having more unburned patches, excuse me, but and then grazed areas are more suppressible. So what they've actually shown is when a fire comes up to a grazed area, it will actually slow down, and so as it slows down, that means the flame length, the height of the flames, will actually get shorter, and that allows us to what we call directly attack the fire at that point. The effect varies obviously by community composition, and again, I've got this, there needs to be a strategic and flexible plan here, and that's what some of these groups that are getting together have been doing. And then using targeted grazing to manage annual grasses and keep those low. As I mentioned earlier, unlike conventional grazing management, livestock can be used as a tool for improving land health by performing weed control. And they can reduce wildlife fire and aid in restoration projects. So any questions so far as we're starting to wind things down here? Okay, we've talked about some environmental factors that influence plant response to fire, the time since the last fire. And again, we've excluded fire. So now we're in these conditions where for the most part, it's been a long time. And then the fire weather, what's the weather like before? Is it hot and dry? And then after the fire, does it stay hot and dry, or do we get some more cool moisture and things like that? And then post-fire animal use. And so they say after a fire, we should keep critters out of there for at least a couple years. And then I've talked about plant competition earlier, how plants compete with each other for soil moisture. And we have bare ground like this picture you see here. Any soil moisture that's there is more apt to be evapotranspirated or evaporated out of the soil. And so when we have vegetative cover, even though the plants are taking up water, they can help hold water at the same time. It's kind of like a mulch. All right. So my slides jumped ahead real quick here. Weather and climate is the most important factor in long-term changes to rangeland plant communities. And then the degree of plant regrowth, again, depends on survival of what I call photosynthetic material. Some grasses or sage are like the plants that are going to come back and photosynthesize and start reproducing. And again, growth and reproduction of one plant can be hampered by another, or resources required by one plant are reduced by another. So all these factors come into play on how we, on how plants respond to fires in their community. Lastly, here's a picture of a ground fire, and I think we can all envision that. Here's a picture of a surface fire, and we can see the embers spreading up across the top there. And then this is what we call a crown fire. And crown fires are usually stand replacing fires where all the trees in the crown are destroyed. And everybody likes to talk about the Yellowstone fires of 1988 and how it just completely burned all of the lodgepole pine and almost the whole ecosystem of Yellowstone National Park. Well, fortunately, most of our ecosystems are able to adapt or overcome. They're fairly resilient for the most part and are able to overcome. And what I'd like to say in summary is we live in a fire environment. We're learning to adapt to it. We're learning how to manage for it. But again, plants can survive and thrive for the most part. So with that, if you have any questions, I'll be happy to answer those.
I don't have any. I'm not hearing anybody else. Nikki, do you have any questions? All right.
All right. Well, thank you, everybody. I appreciate this opportunity to talk to you a little bit about fire. It is a big, broad topic, and you can spend 4 years getting a degree in it here at the University of Idaho. We also have a offered degree in rangeland, where you learn to manage the rangeland, and usually you'll take a fire class that goes along with that and wildlife classes. Anyway, thank you, everybody. I appreciate the time, and good luck with the Skill-A-Thon.
Fantastic. Thank you, Randy. We really appreciate your time today. And everybody who is either tuned in at home or watching this in the replay, I do want to share real quick on my screen that we have, here we go. So we have a couple of more sessions coming up. So next Friday, we'll have Brad Stokes and Bracken Henderson, who are both University of Idaho Extension educators, discussing rangeland pollinators and soils. And then the following week, the last week of October, we'll have Jim Eakins, who's a University of Idaho specialist in water quality, and he will be discussing watersheds. So tune in again in the next couple of Fridays at 3:30 Pacific time, 4:30 Mountain time. And you can register for those conferences or those webinars at this website right here, http://bit.ly/2020 ID 4-H range info. And don't forget the conference will be held, or the contest, sorry, will be held on November 14th, and make sure you get registered for that by October 30th. All right. Thank you all. Have a great day.